to 0, cos 2x minus 1 divided by cos x minus 1. See here we have the identity, we have the formula 1 minus cos 2x, right? 1 minus cos 2x is 2 sin square x, right? So here everywhere in calculus we have to apply trigonometric functions formula, trigonometric identities, right? So here that is the reason we say trigonometric functions are very important. See here you have to study all the formulas of a trigonometric functions. So here limit x tends to 0, cos 2x minus 1 divided by cos x minus 1. We have 1 minus cos 2x is 2 sin square x, right? 1 minus cos 2x, that is equal to 2 sin square x. Okay, now let us apply this one. Let us write limit x tends to 0, 2 sin square x divided by, see, okay, before that we know that 1 minus cos 2x, right? So let us write it, okay, take minus outside from numerator and denominator also, so that we will get 1 minus cos 2x. We have the formula 1 minus cos 2x, right? So here we can write 1 minus cos 2x divided by 1 minus cos x, right? So taken minus outside from numerator and denominator, so it is cancelled. So here 1 minus cos 2x divided by 1 minus cos x. We have 1 minus cos 2x is equal to 2 sin square x, right? So limit x tends to 0, 2 sin square x divided by, see what about this one? 1 minus cos 2x is 2 sin square x, okay? So 1 minus cos x, see when it is 2x, it is x, that is, it's a half, right? That is 2x divided by 2, okay? So when it is x, here x by 2, okay? So 1 minus cos x is 2 sin square x by 2, okay? Then, and one more thing, see here we cannot cancel because here sin square x, here sin square x by 2, okay? So, let us how to make it x by 2. See, we know that one more formula, that is sin 2x is 2 sin x cos x, right? Sin 2x is 2 sin x cos x, okay? So here only 2 sin square x, okay? Let us see with this 2 cancelled, okay? Now let us write this one, limit x tends to 0, sin x, sin square x means sin x whole square, right? Okay, sin x whole square divided by sin square x by 2, okay? Then here we have sin 2x is 2 sin x cos x. Sin 2x is 2 sin x cos x, okay? If it is 2x, it is here x, that is half of this 2x, okay? So here not 2x, only sin x, okay? So sin x can be written as 2 sin x by 2 cos x by 2, that is half of this x, okay? So here limit x tends to 0, 2 sin x by 2 cos x by 2 whole square, okay, divided by sin square x by 2, okay? That is limit x tends to 0, here 2 square become 4, sin square x by 2, taking square, okay, cos square x by 2, okay, it's a square, divided by sin square x by 2, okay? Now see here, this sin square x by 2, sin square x by 2 cancelled. Then remaining 4 is constant, so let us take it out from the limit. 4 into limit x tends to 0, cos square x by 2. Now apply this method, that is direct substitution method. So put x is equal to 0, substitute x is equal to 0, what we will get? 4 into, put x is equal to 0, cos square 0 by 2 is 0, so cos square 0, cos 0 is 1, so 1 square, that is 1, so 4. So 4 is the limit of this function. See the next question, evaluate limit x tends to 0 cosec x minus cot x. See, you should understand. See, on seeing this, you should understand. So, what is the next step? So, for that, you have to, you should be aware of trigonometric identities, all the trigonometric identities, formulas. So, for that, you just take a paper and write all the trigonometric identities, and every day you go through this just for 5 minutes. So that it will be in your mind forever. Okay. So, here, this function, that is a trigonometric functions. See, cosec x minus cot x. See, on seeing this, you should understand. See, what is the next step? What is cosec x? We know that cosec x is 1 by sin x. Okay, so like that you have to think. So, see, if you know all the identities, it will be very easy. Okay, so limit x tends to 0, cosec x. So we can write cosec x as 1 by sin x, right? We know that cot x is cos x by sin x. Cos x by sin x. So here, that is next step, limit x tends to 0, sin x. So same denominator, directly we can write 1 minus cos x divided by sin x. See, if it is 1 minus sin x, you just write the formula 1 minus cos 2x. What is 1 minus cos 2x? 1 minus cos 2x is 2 sin square, right? 2 sin square x. 1 minus cos 2x is 2 sin square x, right? 2 sin square x. So 1 minus cos x is 1 minus cos x is 2 sin square x by 2. Okay. So here directly write this one formula, that is limit x tends to 0, 2 sin square x by 2 divided by, here sin x, sin 2x we have written already. Sin 2x is 2 sin x cos x, right? Sin 2x is 2 sin x cos x. Sin 2x is 2 sin x cos x. And sin x is, what is sin x? It's half, that is 2 sin x by 2 cos x by 2. Okay, that is, if it is x, here x by 2. Okay, so 2 sin x by 2 cos x by 2. So here we will write 2 sin x by 2 cos x by 2. So here, see, 1 sin x by 2, 2 cancelled, sin x by 2 cancelled. So sin x by 2 divided by cos x by 2 is tan x by 2. So limit x tends to 0, sin x by 2 divided by cos x by 2. That is nothing but limit x tends to 0, tan x by 2. Now apply x is equal to 0. What you will get? Tan 0. Tan 0 is sin 0 by cos 0. Sin 0 is 0, cos 0 is 1. So 0 by 1, that is 0, right? So tan 0 is 0. Okay, so here 0 is the value of this limit. See this fifth question, limit x tends to 0, x sec x. See, first apply x is equal to 0, what you will get? Put x is equal to 0, 0 into sec 0. Sec 0 is nothing but 1 by cos 0, cos 0 is 1, right? So 1 by 1, so 0 into 1, that is 0. Okay, so you will get 0. Next question is, find limit x tends to 0 f of x, where f of x is equal to x by modulus x when x not equal to 0 and 0 when x is equal to 0. See, here function is given. So first of all, see, we have to check whether this limit exists or not. See, for that we have to find left hand limit and right hand limit. If it is equal, we can confirm that is exist. Okay, the given limit is exist. Then after that only we can find the limit. Okay, so here first of all let us find left hand limit, that is limit x tends to 0, right? So x tends to 0 minus f of x, that is equal to, see here when x tends to 0 minus means x is approaching to 0 and less than 0. Okay, that is x is very close to 0 and less than 0, not exactly 0. So it is x not equal to 0, okay, and it is very close to 0. So the function is x by modulus x. Okay, so limit x tends to 0 minus, so x by modulus x. Okay, See, if x is equal to 0, then the function value is 0. Okay. But here, x not equal to 0, x is very close to 0. Okay. And it is less than 0. So here, we will take x is equal to 0 minus h. H is a very small number. Okay. And here x is very close to 0, right? And it is less than 0. Therefore, we will take 0 minus h. Okay. H is a very small number. So after subtracting, we will get a very small number that is very close to 0. Okay. So here we are taking x is equal to 0 minus h. Okay. That means, see, when variable is changing, limit will be changed. Okay. So here when x tends to 0, that implies h tends to 0, right? Put x is equal to 0, you will get h is equal to 0. So h tends to 0. So the limit will become limit h tends to 0. X is nothing but 0 minus h. 0 minus h divided by modulus 0 minus h. That is equal to limit h tends to 0 minus h divided by modulus minus h. Okay. That is equal to limit h tends to 0 minus h divided by modulus minus h means h itself, right? So h, that is equal to limit h tends to 0 minus 1. So limit of any constant function, constant itself. So that is minus 1. Now we have got left hand limit value is minus 1. Okay, now let us find right hand limit. Okay, that is RHN, right hand limit. So here x is approaching to 0, that is greater than 0. Okay. So here limit x tends to 0 plus f of x, that is equal to limit, here also the function is x by modulus x, because x not equal to 0. X is approaching to 0 and greater than 0 but not equal to 0. The function is x by modulus x. X by modulus of x. That is equal. Okay. Here x tends to 0 plus, right? So here also we are taking, let us take x is equal to 0 plus h. Why? Because this x is approaching to 0 greater than 0. Okay, that is right of 0. Okay, so 0 plus h. H is a very small number. So 0 plus h. Okay, so x is equal to 0 plus h. So here also variables, when variable changing, limits will be changed. So when x tends to 0, that implies h tends to 0. Put x is equal to 0, you will get h is equal to 0. So the limit will become, I will write it here. The limit will become limit h tends to 0, that is x by, so x is nothing but 0 plus h divided by modulus 0 plus h, that is equal to limit h tends to 0, h divided by modulus h, so that is limit x tends to 0, modulus h is h itself, so h by h, that is 1. So here limit of x tends to 0, limit of any constant, that is constant itself, so it is 1. See here we have got LHL, that is left hand limit value is minus 1 and right hand limit is 1. Okay, that is not equal. That means we can write it as limit x tends to 0 minus f of x not equal to limit x tends to 0 plus f of x. Okay, that is left hand limit and right hand limit are not equal. Therefore, this limit does not exist. Okay, limit x tends to 0, f of x does not exist. Limit x tends to 0, f of x does not exist. See the next question. Suppose f of x is equal to a plus bx when x less than 1. 4 x is equal to when x is equal to 1 and b minus ax when x is greater than 1. Okay. So and if limit x tends to 1, f of x is equal to f of 1. Okay. Then what are the possible values of a and b? Here limit x tends to 1, f of x exists and its value is f of 1. F of 1 is nothing but 4. Okay. F of 1, that is 4. When x is equal to 1, f of x value is 4. That means f of 1 is equal to 4. So what are the possible values of a and b? Okay, let us see. First of all, let us write. It is given that limit x tends to 1 f of x is equal to f of 1, that means is equal to 4. Okay, and we know that the value is 4 means, see, limit of the function value is exists, that means the limit exists and left hand and right hand limit are equal, right? That means limit x tends to 1 minus f of x, that is equal to limit x tends to 1 plus f of x, and that value is f of 1, that is equal to 4, right? That is equal to f of 1, that is by the definition of limit. Okay, so if the limit, here it is given that limit x tends to 1, f of x is equal to f of 1, that means that limit exists. Okay, and its value is 4. Therefore, left hand limit and right hand limit are equal, that is equal to 4. Okay, now let us find first of all a limit x tends to 1 minus f of x, that is equal to limit x tends to 1 minus f of x, that means x is approaching to 1, okay, and less than 1, approaching to 1 and less than 1. So here what is the function? A plus bx. Okay, so here also let us take x is equal to 1 minus h. Why? Because x is less than 1, right? So here let us take a small number, that is h. So x is equal to 1 minus h. When x tends to 1, that means substitute x is equal to 1, what you will get? H is equal to 0. So when x tends to 1, h tends to 0, right? So here h tends to 0, the limit will become limit h tends to 0, here this limit will become limit h tends to 0, a plus b into 1 minus h. That is, so here that is equal to limit h tends to 0, a plus b minus b into h. Okay, so that is equal to, here limit h tends to 0 of a is a itself. Okay, so here we can write limit h tends to 0, that is algebra, from algebra of limits. Okay, minus limit h tends to 0 a bh, right? Okay, that is equal to, here it is a itself plus b, that is limit of a constant is constant itself. So a plus b minus, here put x is equal to 0, what you will get? 0, right? So here we have got a plus b. So here left hand limit, that is limit x tends to minus 1, x tends to minus 1 f of x, that is equal to a plus b. Okay, and now let us find right hand limit, that is limit x tends to 1 plus f of x, that is equal to limit x tends to 1 plus when here also x is approaching to 1 and it is greater than 1. 1 plus means x is approaching to 1 and greater than 1. So when x is greater than 1, the function is b minus ax. b minus ax. So here also let us take x is equal to 1 plus h. Okay, because x is greater than 1. Therefore, let us take a small number, very small number, that is h. Okay, so here x is equal to, let x is equal to 1 plus h. Here also when x tends to 1, h tends to 0. Therefore, the limit will become limit h tends to 0 f of x, that is equal to limit h tends to 0 b minus a into 1 plus h, that is equal to limit h tends to 0 b minus a minus h. So here also we will get here subtract this one, means separate this one. Okay, limit h tends to 0 b minus limit h tends to 0 a minus limit h tends to 0 h. That is from the algebra of limits we have already studied, that is limit of a sum of two functions, that is equal to limit of a function sum of a limit of those two functions. Okay, so here also we can split it, limit h tends to 0 b minus limit h tends to 0 a minus limit h tends to 0 h. So last term will become 0, right? Limit h tends to 0 see here we will get limit h tends to 0 b minus limit h tends to 0 a minus limit h tends to 0 h, that is equal to, it's b, it's a, it will be 0, that is b minus a. And we know that left hand limit and right hand limit are equal to 4, right? Okay, that we have already written before. So here what we have got, left hand limit a plus b. So a plus b is equal to 4 and b minus a is equal to 4. So what are the values of a and b? Add these two equations. Let us take it as 1 and take it as 2. Okay. So a plus b, add these two, what you will get? 2b is equal to 8, that implies b is equal to 4. If b is equal to 4, a is equal to, if b is equal to 4, a is equal to 0. So the possible values of a and b are a is equal to 0 and b is equal to 4.